Just getting the names on the tape. For those who haven't heard this, this is for archival purposes, and therefore, knowing how librarians are, any label that goes on this will probably fall off in 100 years from now. Look at this and say, who are these people? What is this all about? So we have to say what we're doing and where we are.
Yeah.
At least I can hear the audio. I'm just going to say that. Today is the 25th of April, 1983. We're in Rehoveth, Israel, at the Weizmann Institute for Science. We'll be discussing the construction of the Weizac computer, which we began discussing yesterday. There are 2 other rolls of tape to look for. And then we'll continue on the discussion of the Golem computer, which was built in the 1950s and 60s. Okay, why don't you just say your name so we have that.
Yeah, and I'll set example.
And you can say something.
Okay, Phil, you want, so he can set his audio. Just state your name.
My name is Philip Rabinowitz.
Okay. I'm Gerald Estrin.
I'm Hans Jarosch. I'm Riesel.
Okay. All right, we're continuing today our discussion of the building of the Weizac computer here, with some attention to how the individuals who participated came to this country, came to join this project, what kind of computer culture they may have brought with them, and where possible the impact of this particular project that they felt took place in the country here in Israel and possibly any place else that they went. Yesterday we had primarily a concentration on the hardware development of the Weizac and some of its applications, and today we wanted to really pick up the very important issues of software development around the Weizac itself. And there were, really, 2 principles, I'd say, in that process. Hans Jarosch, who came earlier in the game from the United Kingdom, and Philip Rabinowitz, who came from the United States, having also participated very actively in the Whirlwind project. And what I'd like to do is, first, Hans, I'd like to, pick up from you, and if you could say something about what brought you to Israel, how you came here, and then how you became associated first with the Weizac project. So why don't you start from, the United Kingdom, what you were doing there.
Okay, in end of 50, I started working at the Cambridge computer lab under Professor Wills. I got into this somewhat by chance. I had been working a couple of years for Rotal on aerodynamic research for propeller blades, and I had been involved in some...
was that in Cambridge?
No, this was in Gloucester.
Okay.
I'd been doing some computing, and at that time there was no real computer around, so I went up to Rolls-Royce and worked with a machine called Power Samus calculating punch, which is completely mechanical, which has pins like fingers that go through punched cards. And we did some analysis of finding eigenvalues of matrices for the solved problem of propeller flutter. We finally, this wasn't a very good solution. We finally got them to use accounting, calculating hand calculators, and they solved matrices of the order of 24 by hand, getting the first about 4 eigenvalues and eigenvectors. This had been done previously by hand using planimeters, and it took them 6 months before, and now it took them about 2 weeks, so it was some improvement. So I was very interested in finding some better way of doing computing, and I'd left Rotal, and I was living at that time in Cambridge, and well, it's a long story, I don't want to go into it. why I was there, but anyway, I was looking for a job, and I saw that they were looking for staff for the computer lab, and this I was very interested in this because I'd been involved in some heavy computing before, and I got into this.
That was Computer Lab Wilkes?
Wilkes,
Computer
yeah,
Lab,
yeah. I worked with Tony Brooker.
So did you apply to join the Wilkes lab there? Or?
They had an opening, and I went to see them, and I got the job.
Did you see Wilkes at the time?
Sure.
Did he interview you?
Yes, yes.
Who else? Do you remember?
Tony Brooker.
Okay. And this was 1950?
1950, yeah.
1950,
yeah.
okay.
1950, the end of 1950. I'd more or less made up my mind to join my parents here. And plans were more or less complete already by the time I started working there, but it took some time, and I came in April '51.
What was your assignment in Wilkes' laboratory?
Okay. I worked on the Weizac 1 with Tony Brooker, and we were solving partial differential equations using a Liebman procedure.
So the Weizac 1 was operative?
Sure.
This was 1951 or 50?
End of 50,
End of 50.
Yeah. It had, it was supposed to have 1,024 words.
There was delay line.
Delay line. They were in two separate thermally controlled tanks. They were never synchronized properly, and usually only had 512 words. And even with this, you could do some useful work. The interesting thing that we had to do was to find out when the process had converged, and we would look at the scope, which showed the bits in the memory, and we just stopped. When the thing stopped moving, we knew the thing had converged, and then we would.
When there was no more change in the bits in the memory.
Yeah, and we could. There was even a way to clear the memory by going around and putting your finger on the grids of the tubes.
Okay.
That
took more than 10 microseconds, as we were talking about, yes. Okay, so you were working there how long?
About 5 months.
And, sorry, going to proceed from there, and then you made plans to join your parents in Israel?
Yeah, yeah.
And you came here?
Yeah, I came here, and I had graduated as an aeronautical engineer, so I had some introduction to the Air Force people here, and I joined the Air Force, and I was there for 3 years in the Air Force. In '54, I was just finishing my contract when I saw that the Weizmann Institute were looking for electronic engineers, and I had a hunch that they would be building a computer, since it was about time the Institute had one, and I offered my service as a programmer. And
who was the first one you saw?
Professor Pekaris. He interviewed me, and he realized I wasn't an electronic engineer, but that I could start helping with a project. And I started working.
But you told me, and he hired you for part-time?
Yeah, I was, since the machine was not built, wasn't finished, it was suggested I should do 1 day a week with Riesel and 6 days a week with Professor Pekaris.
Okay. And did Zvi interview you at the time? Do you remember?
Probably.
So, on that 1 day a week, at least, what did, what went on with the Weizac that you recall?
The first project was to write test routines so that we could test the machine as it was being built, and if there were any problems, we would be able to find them.
And what language did you write in?
Oh, this is pure binary.
Okay.
Punch paper tape.
And so
there was not even an assembly language program that you could use symbolic at that time. Anyway, afterwards there was later on there was an assembly program essentially with symbolic addresses.
Who wrote that?
Oh.
Yeah. Do you remember?
I don't remember when this.
I don't remember. I didn't know there was one. Yeah.
Wait a minute. Benjamin Scherf. He wrote it.
I don't think it was used.
Maybe, but he says he used it. You used it.
I had it.
You had it, and you used it. And do you think, as you recall, would that have been, let's say, after 1955?
No, I'm sorry. It wasn't Benjamin Scherf. we had somebody come from England.
Mm-hmm.
I still have the flow charts.
It wouldn't have been. Peter Wegner was here. He didn't stay with us very long.
Peter Wegner wasn't concerned at all with computers in those days. He was just programming, but he wasn't on the systems. No, it was somebody from England.
It didn't count. Nobody used it.
Nobody used it, yeah.
Okay.
All right, so as you recall, I mean, you did really were two things. One was to generate test routines to be able to test the machine when it was finished, and then for Peckerus, you probably did some other programming. Do you remember what problem you worked on for him?
Yeah, geophysics.
Uh-huh.
A lot of programming.
You don't remember a particular problem?
Yeah,
You do.
the free oscillations of the Earth.
Okay, yeah, that's something that he mentioned yesterday.
We worked on that. At the beginning, we used, we did not try and solve the differential equation, we used the variational method, and we had to compute very many integrals using the computer.
And do you remember writing any programs for use of the drum? Because in fact there was no core memory, until
much later in
1956. Because there was some early computation done. It was after I left that in fact they finished the drum and got things going. And Peckerus reported that there was some computation, which in fact the first paper that he wrote about work done on the Weizac was still done with the drum memory. And you have any recollection of that? I know it's hard.
No, I was never really too concerned with where the stuff is stored, as long as it is stored.
Right, okay, sure.
We had the Vegematic later, and there it was, you had to write optimum addresses, which is much more complicated. But here I don't remember that we had anything like that. We just wrote the program and it...
I think some of these things may come to mind. I think we're going to really switch to Penny Rabinowitz, and let's try and extract, some of the things. Introduce yourself again and say what brought you here, where you came from.
All right. I'll start. My name is Philip Rabinowitz again. At the end of 1948, no, in the middle of 1948, I just finished a master's degree in mathematics at the University of Pennsylvania, and some people from MIT came down to recruit mathematicians for their servo mechanisms laboratory, and I was recommended by my department head, and I was interviewed, and I was given a job at MIT. The head of this turned out to be the numerical analysis group of the Whirlwind project, which was directed by Professor Philip Franklin, who is a well-known mathematician, the author of several books on advanced calculus. So I came up to Boston in about September 48, and I spent a year at this group, which included some people who subsequently became quite well known in the computer field. There was Alan Perlis, who was working on numerical solution of integral equations. There was J.W. Carr, who I remember was working on what he called the two-register method for working with floating point numbers, because all computers were fixed point computers, and he had this method to have the exponents separately and the antecedents separately. That's a two-register method. There was Charlie Adams, who was developing the programming language. There was Alex Orden, who was working with linear equations, I guess. And there was Edgar Reich, who became a mathematician subsequently. He was also working on the iterative methods for solving systems of linear equations. And I came there, my first job was involved with determining existence conditions for systems of ordinary differential equations, because one of the things they wanted to use the computer, which hadn't yet been built, was to simulate an airplane, and they wanted to determine whether the differential equations for the motions of the airplane, that there exists a solution. Subsequently, I got involved with the numerical solution of systems of differential equations and did some research on that subject. I must say that when I came to the project, I had no background in numerical analysis, because numerical analysis was quite in a primitive state at the time. Now, other things which I remember doing at the Whirlwind project, we had what is called an applications study group, which were trying to think of things to use the computer, which, as I say, was not yet built, although we were writing programs in machine language for the computer. Had no chance to check them out, but that was preparatory work.
How big were these programs that, like were written without checking them out?
They were a couple of hundred orders at least.
Yeah.
I remember one project we were at was when this fellow Gordon Welshman came from England and started to think about using the computer for air traffic control. We decided to try to work on a simple problem, which was guiding a ship through a channel.
Okay.
And we wrote a program. This was, I think, Ted Hildebrand and myself wrote this program for guiding a ship through a channel.
You see it in all the electronic games now. Yeah.
Well, did you know that Gordon Welshman worked on computers during World War II to break codes?
I know he worked. I know that Gordon Welshman worked. He was in England. I know that he came from England to MIT.
Did he indicate that at the time?
Huh?
Did he indicate that at the time?
He's a reserved Englishman. He wouldn't say anything.
And besides, it was classified, wasn't it, or not?
It was classified.
That's right.
Yeah.
Professor Kickers worked there too.
So that was my year at Whirlwind. Then
So that was 48 to 49?
48, 49.
Yeah.
Then, because of family reasons, I left the project, went back to Penn and got my PhD in pure mathematics. And in 51, I graduated and I tried to find a job. And
Who did you work with at Penn
in
your PhD?
This was with Professor Walter Gottschalk, who it was in topological dynamics. Now, I tried to get a job in 51, and I applied several places which needed people with some computer experience, and I got this job at the computing laboratory of the National Bureau of Standards. I was interviewed by Franz Alt, who was the head at the time.
Right.
So I came to work at the computation laboratory in September 51, and I worked there until May 55. When I came to the Bureau, the SEAC, the Standards Eastern Automatic Computer, was already working, and they had quite a big group there. One of the main subgroups to which I was not put in was the Air Force group, which were working on linear programming.
That's
algorithms.
right. Okay, continue.
But I was assigned to general programming tasks. The SEAC was a 4-address machine, and I guess it was 16 operations. It was on fixed point. The fixed point was after the second bit, so you could have numbers less than 4 in the SEAC. And it was a 40-bit machine, and we programmed in hexadecimal, pure hexadecimal. And we had this nasty job of combining 2 hexadecimal addresses into which were each of 3 digits into a 5 hexadecimal word. And that was a great source of errors. Of course, everything was done in absolute, all those subroutines were written in relative. I did some work on a nerve fiber problem. Somebody from the NIH came, which involved solving a system of differential equations. I remember this was my one big failure in that we did some computations and we came out with a paper, and then these computations were checked, and it was turned out that in one of the steps of the computation, an overflow had occurred, which was undetected, and it was just a stupid mistake because I should have interchanged 2 orders and had a divide before a multiply, and everything would have been okay. Anyway, we had to publish another paper
to correct the
other paper. Then, to my great fortune, I was assigned to work with Professor Philip Davis. He had come to the National Bureau of Standards, and he was working on a project for solving partial differential equations using the Bergman method of particular solutions. And he was assigned a programmer to work with him who had no mathematical background, and he was stuck. No progress was made. So I was assigned the job to work with Davis, and we established a very good rapport, and we sort of worked on that problem, and then we started working on other things together, mainly problems involving numerical integration, and we established, I would say, a lifelong collaboration.
Which is still going on, yeah.
That's a lifelong.
Yeah.
Now, I have always been a Zionist, and I always wanted to come to Israel. As a matter of fact, I was almost on my way to Israel in '49, but because of family illnesses, I had to stay on in the States. And around 1954, after our second child was born and my draft classification became 3A, so I was free to leave the country because before that, I was I was exempt from the draft because I was working at the bureau. So as soon as my grade classification was changed, I started to look for possible employment in Israel, and then I heard about the computer at the Weizmann Institute, and I got in touch with Professor Pekaris, and I received a positive reply. And in May 55, I arrived.
So in fact, this was
Israel.
right after we had left.
Yeah, you had left. The computer was operational with the drum, and I immediately started writing utility programs for the Weizac, namely binary to decimal conversion, decimal to binary conversion, loaders, and subroutine incorporating routine. And of course, the Weizac computer was a one-address machine, which is different from the computer which I was used to, the SEAC, so it took a little while to get familiar with the computer and the order code. But it was the same hexadecimal with its problems. It was easier. There was 10 hexadecimal digits, 2 for the order and 3 for the address, so there wasn't this difficulty which we had in the Weizac. So
in the SEAC.
In the SEAC.
Yeah.
So I started working on these auxiliary programs, and then very shortly I got sucked into working on various applications.
Do you remember any first impressions, when you came here? Penny, when you entered this scene.
I entered the scene, the first thing I know was that Hans got a hold of me.
Yeah, and what happened?
And he showed me the order code and everything about the computer. Essentially, my first contact with the computer as a computer was with Hans. And he told me what was done up to then, and then I took off.
Was Avi Ezri here at the time when you arrived?
Yeah, Avi Ezri was here, and Tzvi was here, and
do you remember it being a friendly group? Easy?
Oh yes, it was a very friendly group. We had parties every once in a while, and I used to give my monologue about the football game, which everybody remembers, and there was also quite a bit of hand computation going on at that time for Pekaris, computing integrals, and I remember that one of my big contributions was to show them a better method to compute integrals using Gaussian integration rather than the method they were using, which saved them a lot of time. And finally, we got this also implemented on the computer.
Compared with what you had encountered at SEAC, did you feel any weakness in the architecture of this machine? I mean, there you mentioned already the 3 address.
One of the
code, but was there?
Well, since I came from SEAC, and in SEAC we had the same paper tape input and output, although at the time when I was there they had these, they had a cartridge with a magnetic wire, which is the only place I think they ever had such a thing, and there was an inscriber and an outscriber, which but the cartridges, of course, these magnetic cartridges are always snapping. Yeah. And but of course that was a little bit better than the paper tape input and output. They had their magnetic tapes. They used to call them Pikes Peaks, which we didn't have here. Yeah. But see, if I would have come from a place which was using IBM input, hard input and output, I would have been very much discouraged by the situation here. But I guess that's one of the reasons why the writing an assembly language code was not too feasible at the beginning. At the beginning, I remember, the only read order was to read hexadecimal. There were 2 read orders subsequently, but at the beginning there was only the read hexadecimal, and then later on there was, I think, the 5-7 order for reading alphabetic.
Were there any particular difficulties, like in calling subroutines? I mean, that you counted?
No, I developed the technique for calling subroutines, which was you clear, you load the accumulator with the address which you're located in, and jump to the subroutine, and then the subroutine would take this address and plant it in its exit place, and when you finish, you go to the and you had to make sure, of course, you had that the address was in the right part. The return address had to be a right-hand address, because thing like that. And when you wrote a subroutine, the relative addresses had an 8 in front of them, and the absolute addresses did not. So when they had to incorporate the subroutine, there were certain absolute addresses which had to remain unchanged, and the relative ones had to be changed. And well, that was the subroutine incorporating routine.
Hans, do you remember Penny's arrival? Do you have any impressions of that, or not? Because you grabbed him right away. Yeah?
Not so much his arrival, but the impact, I think, was noticeable. I think the biggest contribution, that made the computer so much more flexible was the writing of single and double precision floating point subroutines. I think that
as far as the calculations.
Yes, I think that was the biggest improvement.
All right, why don't you continue?
Yes, but even before the computer started working, Penny gave a course on programming. Right, because
when was that, Penny? Do you remember?
Well, in the summer of 1955.
I gave the first course was the summer of '55. It was a course which was not only restricted to Weizmann Institute people. I gave one course in summer of '55, and I gave another course in the summer of '56, which also included some numerical.
Do you remember how many people attended these courses, roughly?
At the beginning or at the end?
First, beginning and then. Give me the two, the max min.
There were at least, I remember, 50 people.
50 people. And would you say half of these from outside the Weizmann Institute?
I remember even one very sad.
Hold it one second.
I think the morning had most of the flights, like coming in and going out.
Reconnaissance.
Oh, there's an Air Force.
Oh, this is
We didn't have much.
Okay, let's continue. So you said
I remember one very sad incident when we decided to give some sort of prizes, recognition to the best students in the course, whether it was the first or the second, and
got it.
And one of the fellows who received this award as a job or something, and he got on his way to the institute. He was driving a motor scooter, and he got involved in an accident and was fatally injured. I still remember that incident. It was very.
It was actually. It came up several times in discussion yesterday when we, were talking about the impact of this project on what went on in Israel. That a large part of that impact were the number of people really who flowed through your courses and learned programming and learned that a computer could work. So you say there were two key courses, one in the summer of 55, one in the summer of 56, and then did that go on?
There were other courses. There was one course for the Central Bureau of Statistics. There was one course for Army people. I remember one course I gave to people at NCR because they had one of their accounting machines was equipped with a teletype punch, which would punch out the data, and I gave a course on how to program and for these.
And they were the first commercial, also computer installation later, weren't they? The NCR people.
Well, they were one of the
Service Bureau, one of the early people.
They were one of the early leaders in the field. I remember giving a course to NCR, and there were a lot of courses in and out. But I started to tell you, I got sucked into various applications, programs from inside the department and from outside the department. For instance, I remember Professor Schmidt coming to do the least square refinement for the X-ray crystallography problem. But unfortunately, his mathematical knowledge was not too good, and his formulation of the problem was not too good to start with. And there was this: you do something, and what he told you, but what he told you wasn't really what he wanted. And that was a.
Was this when, around 56 or?
Yes, it was. There was a little bit later. I worked with Dostrovsky on a problem in the nuclear fission and spallation, and then I remember Professor Rakach coming to the Weizmann Institute. He brought with him a program for evaluating eigenvalues and eigenvectors, which was written, I think, for the Oracle, the Oak Ridge computer, which has a similar had a similar order code, not exactly the same, of course, but a similar one. And I had to transcribe this program for the Weizac. I remember that, and but a lot of my time was for writing these auxiliary routines. As Hans indicated, they had to write the routines for floating point, single precision and double precision. And then once these were available, we, together with Zipporah Altman was in on this too, we developed this interpretive routine, which is a three-address interpretive routine for so you can write things 3 addresses plus the operation, and this was then interpreted as to calls to these subroutines.
Wasn't there great loss in performance?
No, the point since the floating point subroutines took the time anyway, the additional overhead in interpreting the address. Anyway, you would have to, if you want to do a floating point operation, you would have to load one address and load to a floating point accumulator, and then add another address to this floating point accumulator, which was not the regular accumulator. So there wasn't that much degradation by having the thing as interpretive.
When you did
program.
that interpreter, did that let you bring in programs written from any place else, any other software onto this machine, or was really
what other software?
What other software? Okay.
Huh? No, all
from SEAC, for example.
Yeah, that had to be everything had to be. There was
no such exchange.
There was no such exchange. As I say, the only big program I remember being transcribed for the Weizac was the one
that
Rokach brought from the Oracle.
Yes.
Oak Ridge.
Do you remember, was there anything very significant that happened a year, after the core memory was, installed? Was there a difference in the activity with software?
No, it wasn't too much different when the core memory was installed. The only difference I remember was that in one or two of the subroutines, when we had the drum, we had a long shift. Whereas when the core memory came, we replaced that by something, store and load or something, because it was. But like this, we didn't take into account the fact that we were using a drum instead of the.
What about the number of people using the machine? I mean,
the number of people using the machine was 1+.
Yes. Okay.
And as the performance of the machine got better, the one still used the greater portion of the machine. This was always a source of irritation to me.
But by the way, this is what von Neumann told me before I left the Institute for Advanced Study and came here, that if nobody else used that machine, Chaim Pekris would make use of it full time. And if he hadn't told me that, the whole project might have been aborted because there was so much opposition when I first came here. But he lived up to that, yeah?
Oh, yeah. Since you worked on a number of different machines, what was your impression, if you can remember then, comparing then? Where did you feel that computers were going at the time? What were the differences? Did you see one type of machine architecture perhaps dominating? Or was it?
It's at the time when I came in '55 here. Coming from the Bureau, we were still very much a machine language oriented community. There was
That's just a backup.
Yeah.
There was very little in the way of automatic programming, although when I came here, of course, the things took off quite rapidly subsequently in the States, and I believe that whereas